All right, well, welcome everyone to our second New York Uber engineering talk. For those of you who haven't been here before, this is the New York engineering office for Uber. We do some pretty cool stuff here. We have the observability team, which I'm a manager of, and that is basically 18 billion metrics a minute flowing in from every single microservice and computer, et cetera, here at Uber. And we do all sorts of stuff with it, including alerting and tracing and all sorts of stuff that keeps the company functioning. We also have the Uber Everything team here, which is a cross-functional team, including mobile, web, backend, basically doing the logistics and delivery experience for Uber Eats and other new products. Basically, if it's not a human being and it's moving around with Uber, then that's these guys. And if we aren't already moving it, we probably will be doing so soon. We're about 115 engineers and data scientists and product people here in this office, a total of about 250 people and growing. So if you guys are interested in growing with us, you can put your name in over there. This building is quite interesting. It was actually built in 1890 as a warehouse for stuff coming off of ships. And there's actually two train tracks through the middle of the building that run the entire block. So when you leave, if you go out that direction, you can walk out through the big tunnel with the tracks. Very happy to have Dean Allemang here. Dean is an expert in the Semantic Web, an author of one of the best books, one of the early books and best books on the topic. He's actually trained thousands of people in semantic technology at conferences and for various different companies. He's also on the design committee of the EDM Council's Financial Industry Business Ontology. More recently, following one of his passions of using data to make our lives better and make the world a better place. And most recently, working with Smart Columbus and had a very successful winning Smart City Hackathon project, which he'll probably be talking about. So without further ado, here's Dean.
Thank you, Nick. I'm trying to decide if I want to use this microphone cabaret style or, yeah. So if I can use the clicker and the microphone at the same time. So thank you, Nick. Nick and I actually worked together about 2 years ago, 3 years ago. Am I allowed to say where? Okay, at Merrill Lynch. So, and that's how I got into the finance sector. And we did one of the, to date, one of the biggest deployments of semantic web technology, certainly in the financial industry and probably in the world. And it's still running in production today. And so we're very proud of that. And I said, people that I've worked for, Nick was probably my favorite boss ever. I know it sounds like I'm just, I have no reason to suck up to him now. So yeah, it's really true. I really enjoyed working with him. And so any of you who have the honor to work with him now, I envy you because he's a great guy to work for. So I'm going to talk about linked data for the smart city. So Nick was interested in having me talk about semantic web, and I thought, well, what would be some of the things I'm working on that Uber might find interesting? And so I'm going to talk a bit about this. So first of all, what is smart cities? My little outline for what we're going to do here. And this talk is actually about data. So why is smart city all about data? How do we connect it together? That's what the semantic web is about, is connecting data. And I'm going to end by looking forward into the sustainability of how smart city data, or indeed any open data, is going to be around in another 3 decades, 5 decades, another century. Sort of looking into the future for that. So I live in Columbus, Ohio, and last year, not quite a year ago, I think it was announced at the end of June, Columbus won a grant from the Department of Transportation to become America's smart city. Now, all the Smart Columbus folks emphasize this isn't an award for what we have done. This is an award for what we will do. And so Columbus put together a really amazing proposal. They beat out cities like Austin, Denver, San Francisco, I think it was Pittsburgh. There were about 7 finalists. And one of the reasons that Columbus won is they put together a really good proposal. But another reason, and having grown up in Columbus, I remember this from when I was a little kid, Columbus has always been a test market for all sorts of things. We could talk back to our televisions when I was 13 years old. And now you're going to figure, you better compute my age, because that was in 1973 that we were able to vote on the ending of a TV show in Columbus. That was in 73. When did you start on the internet? This is like 20 years before that. We were talking back to our television in Columbus. The market tests failed. Cube never became something that went nationwide, but we had it for a few years back in the 70s. That predates the Minitel in France. I mean, it was really early. Tested and failed for reasons that you could historically figure out. And that's another reason that Columbus was chosen as America's smart city. Those 50 million have become 500 million from matching funds from Ford, from IBM, from Vulcan, from all of these places. We now have $500 million running around a city of 1 million people to turn it into a smart city. So it's a pretty exciting time to be in Columbus. And then just for fun, the building we're in, and I came in here to see Nick, telling me the history of the building, like he just told you. So this building looks very familiar. I live in a 1865 building that used to be a brewery in the brewery district of Columbus, and the architecture is the same as this architecture. It's like, this looks like my apartment building. So, I'm sorry? Yeah, well, actually, I've got couches too. And you've got couches here. So actually, yes, the couch as well. Mine aren't as fluffy as yours. I have a much more modern sort of aesthetic. But anyway, so when you think of smart city, what a lot of people think of is self-driving cars and orchestrated traffic and so on. And every time I see a smart city talk, somebody has a graphic, something like this one, of smart cars running around. And indeed, one of the smart city projects in Columbus is in fact such a thing. Just this morning, my Smart Columbus Slack channel pointed me off to an article that in the suburbs of Columbus, there's a road for 35 miles that is going to be instrumented with fiber optics and with sensors all along it, so you can watch exactly where the cars are, where they're going to be testing driverless cars in real traffic settings. And interestingly, halfway along that corridor is Marysville, Ohio, another one of our suburbs, which many of you will know is the first plant by a company called Honda in this country back in the 80s. So Honda's sitting right in the middle of this. The article did not say that Honda was behind it, but Honda's name was quite prominent on the map there. So we know that Honda will be testing its driverless cars in Marysville, Ohio. So that is going to be part of what's going on. But we're actually, the Smart Columbus effort is actually a lot broader than self-driving cars and transportation. So there are actually 4 main themes that are going on in Smart Columbus, and they are safety, a thing they call equity, which is kind of a funny word. Notice does not mean ownership in your startup. It means equity as in being equitable, making things available to anyone in the city, regardless of their social standing, race, etc. Economic development, and this notion of sustainability, which was actually the first one on their list. I put it at the end because I'm going to be emphasizing that at the end of my talk. So safety, things about safety in the city, equity, making this available to everyone, economic development, equal opportunity for jobs. One of the things that Uber is in fact working with Smart Columbus on is making it possible for people from the low income part of Columbus, a place called North Linden, to be able to take jobs in other parts of the city when the bus schedules wouldn't allow them to get there on time, or they can't afford a car. How can they get access to services like Uber to be able to get them to work and back, and when they don't have a smartphone? Okay, how do we deal with that? That's one of the Smart Columbus projects. I saw an article that Pittsburgh was very annoyed that they lost Smart Columbus, and the clickbait title was, "Would Pittsburgh have won if Uber cooperated?" That was the clickbait title. And I read through, and I'm afraid, being somebody from Columbus who looks at Pittsburgh as that other place, I thought, yeah, sour grapes. Uber cooperated with us. I don't know what your problem is. So I think there was some sour grapes there. I don't know what their beef with Uber was, but they had a beef. Now, sustainability is actually 2 things. One is what you normally think of sustainability, environmental sustainability. How do we actually be good to our environment so that we can keep doing what we're doing today indefinitely into the future? But also, this is talk about data sustainability. When we're hosting our data, where is it going to be in 10 years? Where is it going to be in 30 years? Who's going to pay for that? If we're having it hosted as open data, how is somebody going to get paid to do that so that it's still there in the future? And we'll talk about that. So why is Smart City about data? Well, let's think about the kinds of data that you could get either from a smart city or you can use to support these applications. A lot of it is static. If you go out to the Smart Columbus sandbox today, you'll see things like where are the bus stops, where are the bus lines. There's a bike share service, very like the city bike share here in New York, that has a bunch of bike racks. Where are those bike racks? How many berths do they have? But then you've got the dynamic version of all that. Where are your buses? How many bikes are in this rack right at this moment? I actually tried this out. I went to that API, and there's a bike rack right outside my apartment. I said, okay, how many are here? And I walked outside. Right, yeah, they got it right. I would have been very disappointed if they didn't. But where are the pedestrians? What special events are coming up? How many people are estimated to go there? Where are the parking spaces? The sorts of things that you expect from a lot of apps of that sort. Then you also, of course, have things like weather data, satellite data. This is often images. So this is dynamic, but it's in a very different form than the structured data that you expect for those first two things. And then a lot of things like the zoning, the political regions, tax regions, and so on. Yeah.
I notice you're omitting a discussion about privacy issues.
Yeah, I'm talking about open data so far. Obviously, privacy is going to be a big deal.
A lot of things like bike rentals,
yeah,
and IDs of renters,
yeah,
and where they're moving, and pedestrians moving, are easily convertible into Big Brother.
Yeah, and that's a problem with open. Yeah, with big data or with open data in general. So this the things that in medicine you have things like HIPAA that protect that, but nevertheless one can work one's way through that. And in this talk, it's not my intention to talk about that, even though it's going to pervade everything here. Yeah. I beg your pardon?
It is the problem.
It's not the only problem. There are often. Yeah. Yeah. And that's not the topic of my talk today. So, yeah. Okay. Yeah, we actually, if I manage, we started a little bit late, so I'm not going to manage to do that. But and things like budget and spending, how the city, the state, the government, how is how are the tax dollars budgeted? How are they being spent? So these are the sorts of data that one can build your applications around. And as Nick mentioned a couple of weeks ago, actually about a month ago, they had the first Smart City Hackathon, the idea being to bring all this data together and get ideas for applications based on this sort of data. One of the themes that I'm going to talk about throughout this talk is the actual availability and accessibility of this data. Because in fact, for the hackathon, they had set up a nice sandbox and a nice API. You get a nice API key that gave you information beforehand how to do it. And so any hacker could get this figured out before they start. And I did all of that and went to the sandbox where they hosted 3 data sets. So, why is that? And we'll sort of talk about that as we go forward. And what can you do about it? And then there's things like census data, demographics, crime data, police reports, data that's already been open for a long time, but how do you get a hold of it? How do you link it together? So one thing I don't have is a clock here. Okay, there we go. All right. So part of the Smart Columbus proposal and the part of the effort that's actually been worked on in the 6 months or so that the projects have been going is a thing called the Integrated Data Exchange. So Smart Columbus themselves have realized that all of these apps, they want to encourage a sort of a cottage industry of building apps based upon the smart city data and then encouraging the collection and storage of data to support more apps. So there's the Integrated Data Exchange, the first thing that they've been working on. It's a place to keep all of the data. So why would we need an Integrated Data Exchange to build this sort of thing? And I want to tell a little story here, of how open data is published nowadays. So this screenshot is actually not from Columbus, it's from Louisville. Louisville has already done, like I said, the award is for the future, not for the past. If someone were to win an award for publishing smart city data already, Louisville would probably win the award. They've done some pretty amazing stuff. Go to, or just Google for Open Data Louisville, and you'll find that they've got quite a lot of data sets that are very well organized. They are published in downloadable forms that are pretty understandable. I don't know how many hackers are in the room, but you would be able to go to Louisville and find an awful lot of stuff out about what's going on in Louisville. So here's an example from their page, and I've just got a couple of them here. So a lot of data is published like this at a clearinghouse, and this is just a web page. You just scroll through it. You have a little bit of a search engine on the top that'll let you talk about topics and keywords, and then you click through and there's a little description of it, and it's kind of up to you as a human being to figure out your data set. And Louisville does a pretty good job of it, so I'd give them an award for how well they've published this stuff. Some others do things like, instead of giving you a downloadable data set that you could build an app on, they'll have a little interface of some sort where you've got some pull downs and you'll ask questions and they'll form a query and you'll get the data back out the other end. I forget where this one is. This I think comes from data.gov. And then the one I'm going to talk about in a little bit of detail is the FBI's hate crime statistics. Now I'm talking about this one not because it's particularly key to Smart City, although obviously it is, since safety and crime is part of the goals of Smart City. But it's a project that I myself did, so I can actually talk about what was going on there. A couple weeks ago, I was at Intuit, and some of my colleagues from Data.World were talking about a project they did with US Census data. It was kind of fun because they were doing the same kind of thing I'm about to show here, and we sort of got ourselves into one of these little pissing matches of, oh, you had to walk 2 miles to school, well, I had to walk 3 miles to school in a blizzard. Well, blizzard, oh, it was so lucky to have a blizzard. Well, we were looking at what we had to do to get a hold of this data that we have a legal right to, in this case from the FBI, and in his case from the Census Bureau, and what we had to do to turn this data into something that we could actually use. So I'm going to tell my story. His story was interestingly parallel, and this is actually kind of typical of how data sets are represented and published in the world today. So this is data from the Shepherd-Bird Act. So back in, I forget, 2011, I think is when it started, Congress passed an act that said that there are certain categories of hate crimes that we need to track. And there are, the way we track them has to do with the demographics of the victim as well as the perpetrator. If it's a hate crime, there's a particular bias. Is it anti-religious, anti-sexual orientation, anti-ethnicity, various categories of that sort, and then breaking that down. Is it anti-Jewish, anti-Muslim, etc. And then where did they happen? What kind of crime was it? Was it an assault? Was it a rape? Was it a theft? Was it and so on? So the FBI tracks all of this as per the requirements of the Shepherd-Bird Act. And another requirement of that act is that this is data that belongs to us, the citizens. It is open data. Anybody in this room, anybody in the world is allowed to see this. And if you go to the FBI's page for the Shepherd-Bird Act, they'll have over here, is there a pointer in this thing? Yeah. Okay, over here on the right, you see there's a number of reports that somebody has put together, the FBI, have put together. You click through those things and you get a nice table here, and there'll be a description of that. And this is how they publish the data for your eyeballs. Now, if you want to actually use this for a smart city application or for cross-referencing for some sort of analysis of changes in hate crime data based upon whatever your theory is that you want to do your analysis on, this isn't the best way to do that. What you'd really like to do is get that raw data and start doing your own processing. And the Shepherd-Bird Act, and this is, people always say, oh, it's a FOIA thing. No, it's actually not FOIA. The Shepherd-Bird Act says right in it, you have the right to this stuff. So if a court says this is not a FOIA applicable data set, that doesn't matter. The act says you have a right to see it, FOIA or not. So this is data that we have a right to see by act of Congress. So that's the way we see it today. Now, what if you actually wanted to look at the real data. How many people in the room would consider themselves software engineers or hackers or something like that? Oh, good. Okay. Then you're going to appreciate what we're about to see and why this is amusing. So this is the format that they were given. And so I wrote to the FBI and said, I'd like to have this data. And they were very cheerful and they were very prompt. And they sent it back to me almost immediately, like within 48 hours, I had this data. And when the next year's data came out, I wrote back and I had the data within no time at all. So they were very, very cooperative, as the law requires them to be. The law, I don't think, requires them to be prompt, but they were. So here's the way the data works out. You get these records that look like that, bunch of letters and numbers. And the way that these work is that there are certain columns. So the third and fourth column, or the second and third, if you count from 0, like most computer scientists do, is a code for the state that this happened in. And these columns here, and actually you can see that looks like a date, 20140422. That's April 22nd, 2014. Those are a date. And then these columns here, and I think that when I switched this to Google things, the braces moved a little bit. I'm not sure if it's 13C or 3CO, but anyway, a couple of those things are a code for what the offense is. Is it assault? Is it rape? Is it robbery or theft? And so on. And then the location, location, that has to do with the kind of venue. So the sorts of things there are church, synagogue, gas station, school. So places where the thing may have occurred, out open street, private home, that kind of thing. And so every column here has some interpretation of what's going on there. Now, on the page where they tell you about this, because you have to write them to get it, but on the page they'll say, this is a quote, "This may require some programming knowledge to extract the data." And so, and indeed, that is the case. So I spent a week over the holidays when my clients weren't pestering me and taught myself Python and wrote a program to pull that stuff in. Now, how do you know which column is which? They, of course, give you a legend for this. And here's an excerpt from the legend. And actually, this is the location codes I was just talking about: bar, nightclub, bank, savings and loan, convenience store, residential home, all of these things. And there's the code 0102 up to 25. So they, for all of their category systems, the one for the race, one for ethnicity, one for the offense, one for the location, there's about 7 of them. I can't remember what they all are. You've got a little legend like this, and they will happily give you the legend as well. Now, here's where I was able to say to the census guy, "Oh, but it was snowing when we walked our 2 miles. It's like, that's a bitmap. I can't copy and paste from that. I love the groans in the room. I know I've got software engineers in the room because of how the groans are going here. So I had to OCR this, and I had to correct the OCR because OCR only gets a 95 or something like that % if you're lucky. And then take that and do something with it. So this is the kind of situation that we have with open data that we have every right to have. In this case, every right from the point of view of Congress. There's an actual congressional, there's a law that says we have the right to this, but there's no stipulation that it has to be easy. So, or it even has to be easy to find. And the same is true with census data and so on. So as I was going through the Louisville data, I noticed that they actually had a data set there. You know, their data sets were very nicely organized. And there was, in fact, the one that I had up on the first page, which was the Louisville Police Department hate crimes data. Oh, that's interesting. So Louisville's tracking it themselves. Let's have a look. Let's click through that. And sure enough, this claims to be the data that they submitted to the FBI in order for the FBI to do that one. So now it was just as I was preparing this talk that I discovered that. So I actually haven't had time to do the sort of obvious thing of comparing those and seeing whether or not what Louisville says they reported and what the FBI says that they received actually match up. But it is interesting to look into the Louisville data. I don't have a slide for it, but if you crack it open, for instance, the bias is one of the categories. And there were those codes, you know, little 2-digit codes for bias. And that the bias is actually a whole hierarchy. So religious bias, ethnic bias, racial bias, and I forget the other ones are. And then under sexuality, there's anti-gay, anti-lesbian, anti-bisexual, anti-straight, anti-trans, I forget what word they use. They use trans. I'm not sure what word they use. It might be transgender. I'm not sure which word they use. And then other. There's always another. And what they've done in Louisville is that they have a column in their spreadsheet that doesn't use the FBI codes, but uses a mnemonic. And so and you can tell what it is because you've seen what the actual values are. And so you can match them up, but that's a bit more work for you to do. And as a quick aside, another one of the areas that I've done a lot of work in is actually agriculture. There's a group in France called the CGIAR. I forget what the acronym stands for, but their charter is to track agricultural data in the developing world. And one of the problems that they have is they'll get some data. We've grown a crop, and the crop that we harvested had some percentage of beans that have the black spot on them, some percentage that don't have any spot at all, and some percentage that have lots of spots on them because these beans have 3 different phenotypes for their coloration gene. And the data manager there, I've seen a number of talks that she's given, a problem that she faces, she gets a spreadsheet. And the headers of the spreadsheet will say things like one spit and mini spit and no spit or NS, OS, and the different headers. And she knows what the phenotypes are. And so it's really easy for a human being to match this up. You got 3 columns, you got 3 phenotypes, and you got some words. She can even write a natural language thing that gets this right often enough to help her out. Because the problem is I need somebody who would curate the phenotypes for me so I know where to find them. So it's a pretty common problem that you've got your controlled vocabulary and you're trying to match your controlled vocabulary onto your open data sources that you have an awful lot of. And how do you find the controlled vocabulary? How do you reference the controlled vocabulary? How do you match your data to that? So it's the same problem that we're seeing here, but happening in agriculture, and it happens throughout the world. So one of these days, when I have lots of spare time, I'm going to compare Louisville to the FBI and see if they actually agree. So this is a problem that we have across the open data world. We have data from all over the web in lots of formats. If we're lucky, it's just something machine readable like XML or a CSV. If we're kind of unlucky, it's in things like PDFs, which are in principle machine readable, but in practice not so easy. Or if we're really unlucky, in things like bitmaps, which aren't really machine readable at all. Well, kind of, sort of. And we have to do a lot more work there. How do we bring all of this stuff together? And that's this goal of the integrated data exchange that Smart Columbus is talking about. For the data for the smart city, how do we bring this stuff together so that if somebody solves this problem for one data set, like I've just done for the FBI data and Elizabeth is doing for her phenotypes, when someone solves this problem, where do they put the answers? How can the community benefit from all of the work that we're, in principle, crowdsourcing, but it's not going to be crowdsourced if you can't put it all somewhere. And that's what the point of the integrated data exchange for the smart city is. And it's also the point of data.world, which is another service I'm going to talk about a good deal in the rest of the talk. And I even have little, for those of you who like to put stickers on your laptops, I've got some data.world stickers back there if you're interested in doing that. So let's talk about some technology for doing this. The World Wide Web Consortium, the folks who brought you the web, have developed a set of standards, and this is what Nick and I have worked together on back at Merrill Lynch, and I work on with 5.0 and some of the other projects that I'm working with. Standards for distributing data across the web and for bringing it all back together. So how do you integrate all of this data in a global way? So I'm only going to talk about the bottom level of this stack. There's an entire stack that the W3C has developed. I'm only talking about RDF in this talk. If you want to talk about RDFS or SCOS or OWL or whatever, read my book. Or have me come in and do a class or something or other. So I'm going to talk about how it works and how can we use it for smart city data. So let's think about how the web works. We think of the web, there's these documents on the web, they link together. Every document has a thing called a URL, which helps you find it. And then that URL can be mentioned in another document, and that's how we link our documents together. They can be anywhere on the web. I don't think I'm saying anything that anyone in this room is finding surprising. Now, how do you do that with data? So these are intended to be ER diagrams or something somewhat like them. But if you have data sets around the web, how can you link the data sets together? And the point of the W3C standards of RDF in particular is that we use the same infrastructure that we use for the web to do this. And in particular, that means we use URLs to talk about things. We refer to those URLs from one data set to another, and that's how we distribute our data across the web. So I'm going to show you a little implementation of the semantic web done in, well, it was originally done in PowerPoint. Now it's done in Google Slides. So, well, the thing that is the URI or the URL in the web, that's a global identifier that everybody agrees that this is what it identifies, corresponds to the location on the slide. So it's a very minimal implementation of the semantic web. We have a rather limited amount of URIs in this world, but enough for a demonstration. And the topic in this slide is mathematics. It's slightly abridged. There are a few concepts of mathematics that I did not put on this slide, one or two. But I did put on some topics like sphere packing and Fermat's theorem, so at least some of the cool things are here. You don't need to know a whole lot about graph data to figure out what this data set is saying. Wiles and Hales both studied at Cambridge. Wiles solved Fermat's theorem. Hales solved sphere packing. Hales works in geometry. Sphere packing is about geometry, so that kind of makes sense. Fermat's theorem is about arithmetic. Arithmetic, algebra, geometry, etc. are all have a broader term that is mathematics. There's some websites that are about these various topics. So this is data represented in a graph, and that's how RDF does its distribution. It represents data in a graph and then distributes it across the web in a way that I'll show in the next few slides. So for instance, on this diagram, there are several statements. I just read them all out to you. Some of these statements come from Wikipedia. So the fact that Wiles studied at Cambridge and that he solved Fermat's theorem, and that's about arithmetic, you can find that from various Wikipedia pages. The fact that sphere packing is about geometry, you can also find on Wikipedia. So there's a subset of this data. And as you watch these slides, I want you to keep your eye on geometry, because it's one that actually stays in all of them. Geometry and these other things all have a broader term, mathematics. Those are actually Library of Congress subject headings. So that notion of geometry is related to these other things by all being branches of mathematics. And then the fact that Hales worked in sphere packing and geometry and studied at Cambridge all come from his own web page that he has out at Google Sites. And then the things about game theory, this here geometry isn't on this one. This all comes from MazerGames.com. And finally, algebra.com has this information about algebra. Well, that it itself is about algebra. So you take all of these bits of information, and if you superimpose them all, then you get a graph that tells you a sort of 360-degree view about mathematics. Well, this little part of mathematics. Do this on the whole web, and you could actually get a pretty good view even of a complex topic like mathematics. Now, the key to linking these things together is a shared notion of identity. So for instance, that's why I had you watch geometry. As we go through here, that geometry at that particular spot on the screen is the same notion of geometry in all of these data sets. That's what's key in bringing these together, that you have a shared notion of one of your terms. And the way that we do that on the web with documents is with a URI or URL. For the purposes of this discussion, they're the same. So you have a web address. Any web browser in the world will come to the same place with the same address. Any data set in the world referring to one of these things is referring to the same thing. We might disagree in what we say about it, especially if we're talking about politics or crime or religion. We would disagree what we say about them, but we can agree about what's the thing that we're talking about. And that's the part of the semantic web that already exists. That's the regular web infrastructure. So the notion of geometry that's shared across all these things, that's a URL in the semantic web. And all these statements are done with a graph database. And the standard for that is a thing called RDF. So how do we use that to work with some of the data we've been talking about. I'm going to go back to the hate crimes data. So this is actually not tremendously abridged version of the categories that the FBI, as part of the Shepard-Byrd Act, has identified for talking about hate crimes. And there are at least 4 categories of hate crimes that they talk about. Ethnicity, race, religious, and sexual. This is the biases. So it's that each one of those in the actual data set has the word anti in front of it. Actually, every word on this is anti in front of it. So there's an anti-racial bias, an anti-sexual bias, an anti-religious, and specifically anti-gay, anti-Jewish, anti-Asian, etc. So how would we go about comparing the Louisville data to the FBI's master data? So here's a little picture of that. We've got the FBI data here on the left, the Louisville data on the right. They both refer to the same categories. Now, in their own data sets, they use different ways to do that. The FBI uses a little 2-digit code that we saw the legend for, and Louisville uses a little mnemonic. We have to do that mapping, but they're both mapping to the same notion, or at least they should be. And so we can check that out as well. I'm sorry? Yeah, indeed. They kind of looks like they actually are, but we need to check. And then once we find that out, it could be that there's an extension that they have to do, and this happens a lot in this world. But let's assume for the moment that they actually are. They claim to be, and it kind of looks like they are. So let's assume for that. So now what we need to do is to have these things be something that both data sets can refer to. And this we go back to this notion of the URL, the notion of the shared identity. So that when the FBI talks about anti-Black bias and Louisville talks about anti-Black bias, we're talking about the same thing. And we can represent this as a distributed data set across the web. So when we create the RDF data set for Louisville and the RDF data set for the FBI, these actually share a URI in those data sets. And that's how we connect them together to do. Here, the analysis we're talking about is pretty simple. We're just comparing, are they the same or not? But you could actually do any number of aggregated analyses. You could sum them up if that made sense. You could average them. Here, we expect the data sets to be the same, and we're checking whether that's the case. But any number of analyses could be done by cutting across that. And to sort of talk about what Nick and I did back at Merrill Lynch, think about Bank of America, Merrill Lynch. I'm a customer at Bank of America. I never opened an account there. I never opened an account at one of the banks that merged together to become Bank of America. I never opened an account at one of the banks that merged together to be one of them. I opened an account at a bank that merged to be a bank that merged to be a bank that merged to be Bank of America. Who merged with Merrill Lynch? Pierce, Fenner, and Smith. How many databases are inside of that organization? Who knows? But they need to have a 360-degree view of a lot of what they're seeing. That's what Nick and I did at Merrill Lynch, was to build a structure like this with shared vocabularies and had all of these things point together so that we could get a view of all of the data in a single interface. How's that for a 3-sentence description of what we did? So for those of you who like to geek out here, this is what it looks like when you turn that controlled vocabulary into RDF. Actually using a standard called SCOS as well here, which I won't go into, but it's a standard for describing vocabularies. So there's a picture of the bias part of the tree, and you'll see it's a lot of the same things you saw in the PowerPoint version of it, but this one's actually comprehensive. And then here's what it looks like in an RDF notation, so if you actually were to write it down. And there are graph databases that specialize in bringing this stuff in, merging it all together and servicing queries that will cut across it. So that's how you actually take your distributed data and start doing queries across it. Now we started a little bit late. This is supposed to go for 45 minutes and then have questions until 7:30. How should I time the finale of this? So I aim to end at 7:30 and just, okay. So how do we host this data? How do we find the data? If we're going, we now have a standard for how to represent distributed data, what it means to connect it together, but we have to host these data sets somewhere. We have to be able to find them. We have to be able to process them. And so that's what Columbus is doing with their smart data sandbox. So this is the front page of that. And what they've done is to take their data sets, put them in here, and they've got a little API on there, and they document the API, and it comes back in JSON payloads. They have not done this in a semantic web way, so you don't actually know how the things cut across. That's part of what you need to do as an application developer, is to figure that out, and then write your program to do what needs to happen. I'm going to talk about for the next several slides is Data.World. This is a company in Austin, Texas, that got the idea that they could do for open data sets what GitHub does for open source software. So anybody who wants to publish their open source software and get collaboration, have people use it, can go to GitHub and publish this and can keep track of versions and provide various services over these things. For data sets, if I have a data set that I want to publish, then I can go to Data.World and publish it there. I'll let you finish taking the picture. You can have these slides at the end, you know. So I'm very flattered you want to take a picture of all of them, but I'll happily give them to you. So for instance, the work that I did with the Shepherd Bird data, this is the licensing for this data is that it's open to the world. So I'm allowed to republish this. And of course, one of the issues that I'm always hammering at Data.World is that they need to have a way of communicating and hopefully enforcing the licensing around this stuff, because each one, you know, you're talking about privacy, there's also licensing some of this data for pay. If you include this data in something, is it a GPL where it has to be public as well? You know, there's all sorts of licensing things that can happen with data, just like with open source software. So I put together a page where I described the Shepherd Bird Act, gave links to the original FBI data, and published my data sets so that you don't have to write a Python program to pull that stuff out. You don't have to OCR that stuff again. You can just come here. Now, similarly, the state of Ohio has, actually at the urging of the folks at Data.World, so their marketing director works a lot in Ohio. And so she went to the Ohio Treasury and encouraged them. They have some data that is, again, by law, my right to see it. And she worked with them to create ohiocheckbook.com, and then took all of the data in ohiocheckbook.com, which has these lovely spreadsheet style diagrams on it, and put that into Data.World. So now anybody who comes to ohiocheckbook.com can play around with the Excel-like reports that they have. But if you want to do some deeper analysis, then you can come over here to Data.World, where it's all loaded in machine readable form and in fact linked off to other data sets. And then since it's being recorded, I'm not going to say the next thing. So she found out some secrets from ohiotreasury.com. Let's leave it at that. Let's see, what do we got here? Oh, so this is the hackathon. So at the Smart Data Hackathon about a month ago, the idea, and they're going to be doing one of these every 3 months or something like that, and they're figuring out just how to turn this into a recurring thing. Because remember, what Smart Columbus wants is a cottage industry of smart applications on top of the smart city. So they want to get and Columbus is actually a very entrepreneurial city. They want to get the startup community in Columbus working on this stuff. So the first hackathon was about a month ago, and the idea was we'd make a lot of these data sets available, bring data hackers in, and they're going to combine things together with some business idea, and that's going to be, we'll choose the best one. Now, I'm going to show you our award-winning application. I was on the team that won the Best Use of Data Award. It's called Bonsaidata. I'm going to fully confess that the reason we won the best use of data is that we had the only use of data. Yeah, they said we were the only ones standing. And now, why was that? As I mentioned, their smart sandbox, by the time the hackathon began, was only hosting 3 data sets on its own. It did provide several hundred links to other data sets, but they were all links like the ones I've been showing you. And nobody in a weekend is going to solve one of those problems and get that data set going so that they can actually do anything interesting with it. So there were 3 data sets there. And so I looked at this and said, well, I'm I'm not going to get anywhere with these 3 data sets. But as it happens, because of the folks at data.world, an awful lot of Ohio and Columbus data was actually already on data.world. They're building a social network for data. So I went out actually to this particular data set right here. There's a reason why I showed that one. Went out to here and said, well, after all, if people like this, and you can drill down, there's a couple layers, some trees there. And there was a fellow, typical hackathon thing. You find other people at the hackathon saying, here's what we do. He says, well, I represent tree data using virtual reality. Now, I'm a data visualization skeptic. I'm a mathematician. My supervisor at Cambridge dealt in 24-dimensional lattices. You don't visualize that. You write formulas and you prove things about it. So and I actually told Adam, look, I'm a skeptic. If you can actually convince me that you've got a data visualization thing that's interesting, then you've actually done something. So I'm very skeptical about this stuff. And so I've got these trees, and I do my file system using these virtual reality trees. Yeah, okay, yeah, try something else to impress me. He says, well, I was thinking of doing this with budget data, so in the branches of the trees, you could actually see where your money is going. And so I ran that by some other folks. I said, yeah, we could do a tree. You actually see where your money is going and go, oh, that sounds cool. Oh, okay. I'm not sure that I think it's so cool, but an awful lot of people do. He had his VR rig there. I wish he had a big elaborate rig. It's not just a little Oculus. It's a great big thing. And he'd have people put this on and go, oh, this is kind of cool. That's the state budget. And the big branches are where your money's going. Oh, really? Okay. And suddenly they're engaged. And I have to confess, as one fellow, actually he was one of the judges, said, no, I've never got this excited about a spreadsheet. Yeah, and then I thought, okay, the data skeptic in me, or the data visualization skeptic in me is now starting to come around. Okay, here's somebody who is now engaged with this data, and the story I didn't tell about the inside of the Ohio Treasury. They really want the citizenry to be engaged in this data for reasons I won't say. And so, hey, this is doing something. These people are getting engaged in a way that they weren't before. That's value. Even the 24-dimensional lattice visualization skeptic in me had to admit that's value. So that's what we did. We took the checkbook data. Carol Lee from data.world had put that into data.world. That meant I didn't have to do any more work. I just had it there. And Adam told me what form it needed to be in for his trees, and we got it into Bonsaidata. And the next one's a picture, but I can actually do this as a demo. Now, this is a hackathon. It was just a weekend, and it was a little, so, expectation management here. Nevertheless, when it's in VR, it's really cool. So you can see this, and I invite any of you who want to go to bonsaidata.org and play around with this. The controls are pretty rudimentary, but you're seeing here are, he added in a couple of, green trees to make it look like a grove. He's got this kind of mystical thing about trees, Adam does. And well, it's cute. Each of those trees is a budget from a different year. So they've kept, Ohio Checkbook has from 2008 to 2016. The categories that the trees are made up of, and remember how the control works on this machine. There we go. And you can have a look here. These categories in good hackathon style, we didn't have any hierarchical categories for the particular data sets that Carol Lee had in data.world. So in hackathon style, I created some. And so I'm using the same categories across all the trees. And so you see that here, that the category, the big blue category, if you look at it this way, by the way, it looks an awful lot like a pie chart. And if you spin this around that way, yeah, these controls work a bit different than I'm used to. That other has most of them here, but for things like the second biggest one is like educational buildings, that splits into 3 more pieces. And in the VR, it's easier to do this. There we go. And you can see the budgets for each of those as you go around. Like I say, the data visualization skeptic in me says, now come on, you really can get more insights out of this than you would out of a spreadsheet. But I realized that insights isn't really what it's all about. You get more engagement. So one of the questioners, when we gave the presentation, he asked Adam, what insights can you get from this that you couldn't have got from the spreadsheet? And the answer is none, really. In fact, you probably get fewer insights. But it was in this mot de couloir, after we left, it was actually, I was laying awake that night because I tend to have insomnia. I realized, no, the right answer was, you've asked the wrong question. We don't get any new insights. What we get is new engagement. And that's that's what the data visualization skeptic in me, that's what actually brought me around. I invite you to go play with that. I'm hoping that he'll get it working for Oculus soon. If he doesn't, I will. So that you could actually take your little Samsung Gear VR and, you know, do this kind of stuff. And that's kind of what I really like to see with that. You go to your budget and you're actually standing, well, right now you'll stand in the tree. You know, there's the tree right in front of you and you can move around and see it. It'd be nice if you had something with a glove, you know, grab this thing and have a look at that budget item and get that kind of engagement. Go back to presentation mode. Okay. So we're pretty much at the end of the talk. I want to move out into where does this go in the future? All of these logos are from organizations. These are mostly non-for-profit NGOs that manage some kind of open data. A lot of them are in agriculture because that's something that I happen to work in a lot. Open Facts is in pharmaceuticals. These other ones, CGIR, I've already mentioned. MORPC is the Mid-Ohio Regional Planning Council. They have huge amounts of data about Central Ohio having to do with, well, all this, the sort of smart city stuff we've been talking about. Keystone Hub and Agrimetrics are, Keystone Hub is, you know, these are both projects funded by either the EU or the UK, I forget which now, for managing a lot of agricultural data. But here's the issue that all of these folks face. You get some funding from the EU, from the NSF, from somebody, and you collect some data. You do work like I've been talking about in this talk. You put it up on a server, and you put your index on it. You do whatever your theory says is the right thing to do, and then your funding runs out. What happens? Yeah, so, well, that's what happens unless you do something about it, unless you have a sustainability plan. So when I'm talking about sustainability, I'm not just talking about trees living until you know, the middle of the century. We're also talking about what happens to that data. So there's a couple ways around it. One is you actually have a company here. And so will you still be here tomorrow? And these are actually companies. And so I put data.world here, but some of them are general, like data.world. Others are specific to certain verticals. Data discovery is in pharmaceuticals. So in fact, Open Facts, I've worked with this crowd, they ran into exactly this problem. I was an advisor on this, and about halfway through the project, if you think this fellow's a curmudgeon, he's not half as curmudgeonly as I am. Open Facts has put together an attempt at a business model. How can you sell the data? How do you monetize your data so that you can be paid at least enough to keep hosting it? And what they've done recently, it was announced about a couple weeks ago, this company, Data Discovery, has made a business plan of doing just that. And Open Facts basically realized that they couldn't do this themselves. So they've now sold the rights to their data infrastructure to Data to Discovery. Let's hope that they can get a business model that will last them for a while. Agrino is another one that's doing this agricultural data. There's actually kind of a cottage industry of companies doing this, taking different, just like any other entrepreneurial world, taking different business models of how we can monetize data. I mean, monetizing data is something that people do a lot of. And these folks, data.world is doing it in general. Data Discovery is doing it for one vertical, pharma. Agrino is doing it for another one, agriculture. And I think we'll be seeing a lot more of this for smart city data as smart city becomes more of a thing. But even with these solutions, these are companies with business models. They're going to have an exit strategy. Will this become something that someone like Google can actually take on and do indefinitely? Will Google be here in 2050? What will the world look like in 2050? A lot of these folks are looking at agriculture in particular, looking at some demographic information that says by 2050, the world is going to be difficult to feed. We need big data solutions to improve productivity of food. How are we going to keep that data? It's got to be longitudinal. It's got to be worldwide. It's pretty elaborate. So how is that going to happen between now and 2050? What will the internet look like in 2050? What will data systems? I'm not really sure. This is really getting into some weird stuff. So my final slide is that we actually have to think of ourselves as being part of a relay race. Yeah, we're going to have some business models, we're going to have some NGO models, we're going to have some funding models, whatever they are, they're going to have to change. They have to be Madonna or Cher. They got to keep on moving and be something different each time, or IBM or Monsanto or Nokia, if you want to think of companies instead of divas. They have to figure out how to change who they are because the world is changing faster and faster. So yeah, we get a business model that works for 5 years, that's great. 10, that's twice as great. Maybe 4 times, maybe it's a logarithmic scale. Yeah, but it's also 4 times harder. So that's the way we need to look at this, is that these folks are just the first runners in this relay race, and we need to keep sustainability. And that's why on my very first slide, sustainability had been the first bullet for Smart Columbus. I put it last because I wanted to come here, but in terms of emphasis, that is the key thing. We've got to be able to keep doing this into the future. My really last slide is just my, my logo and who I am. All right, 4 minutes over. Thank you.